Welcome to the first lecture of our Design for Injection Molding course. Today we're unlocking one of the most critical factors in plastic part design, wall thickness mastery. Get this right, and you'll create high-quality defect-free parts. Get it wrong? You risk warping, sink marks, and costly production failures. Let's dive in. Wall thickness is a fundamental aspect of injection molding. It significantly influences a part's manufacturability, strength, and overall quality. Selecting the appropriate wall thickness is crucial for achieving optimal results. This ensures the molded part meets both functional and aesthetic requirements. Careful consideration of wall thickness is essential throughout the design process. From initial concept to final production, understanding wall thickness impact is key. This knowledge empowers engineers and designers to create robust and reliable plastic parts. Mastering wall thickness in injection molding requires a deep understanding of its nuances. This video serves as a guide to navigating the complexities of this critical design element. By grasping the principles outlined here, both professionals and beginners can enhance their injection molding expertise. Wall thickness directly impacts how molten plastic flows during injection molding. Thinner walls offer less resistance. This results in faster, easier filling of the mold cavity. However, excessively thin walls can lead to issues. These include short shots, where the material solidifies before filling the mold completely. Cooling time, a significant factor in cycle times, is also affected by wall thickness. Thicker walls take longer to cool and solidify. This increases cycle times and reduces production efficiency. Conversely, thinner walls cool faster, leading to shorter cycles and increased output. The structural integrity of a molded part is directly related to its wall thickness. Thicker walls provide greater strength and rigidity. This makes them suitable for parts subjected to high stress or load. However, excessively thick walls can lead to sink marks and voids, compromising part quality. Maintaining uniform wall thickness throughout the part is a golden rule in injection molding. Uniformity ensures consistent material flow, cooling, and shrinkage. This minimizes the risk of defects and inconsistencies in the final product. Uniform wall thickness contributes to a more robust and reliable molded part. Non-uniform wall thickness can lead to a cascade of manufacturing challenges. These include warping, where uneven cooling causes distortions. Sink marks, depressions on the surface due to uneven shrinkage can also occur. These defects compromise both the aesthetics and functionality of the part. Uniform wall thickness promotes even material flow within the mold. This ensures all areas of the cavity are filled properly. It also minimizes internal stresses and weaknesses. Consistent cooling facilitated by uniform thickness helps prevent warping and dimensional inaccuracies. Achieving optimal wall thickness tips and tricks. Determining the optimal wall thickness requires consideration of several factors. These include the material used, part geometry, and intended application. Consulting material datasheets and leveraging simulation software can aid in selecting the appropriate thickness. When designing for strength, consider adding ribs or gussets to reinforce areas of stress. These features provide added support without significantly increasing wall thickness. This helps maintain uniform cooling and minimizes the risk of defects. For parts with varying thickness requirements, gradual transitions are essential. Abrupt changes in wall thickness can create stress concentration points. These points are susceptible to failure. Utilizing fillets and radii to smooth transitions enhances part strength and manufacturability. Common pitfalls in wall thickness design. One common mistake is designing overly thick walls. This may seem to increase strength. However, it often leads to longer cycle times, increased material consumption, and a higher risk of defects like sink marks. Conversely, excessively thin walls can compromise part strength and lead to manufacturing challenges. Issues like short shots, where the material solidifies before filling the mold, are common with overly thin walls. Another frequent error is neglecting to maintain uniform wall thickness. Abrupt changes in thickness create stress concentration points. These can lead to part failure. Non-uniform wall thickness also contributes to warping and dimensional inconsistencies. Rectifying wall thickness issues, practical solutions. Addressing overly thick walls often involves strategically reducing thickness in non-critical areas. This can be achieved by incorporating coring or hollow features. These reduce material usage and promote even cooling. For parts with excessively thin walls, increasing thickness in critical areas or adding ribs for reinforcement can enhance strength. Adjusting the injection molding parameters, such as increasing injection pressure or melt temperature, can also mitigate issues like short shots. Correcting non-uniform wall thickness requires careful analysis of the part geometry and flow patterns. Gradual transitions, fillets and radii can smooth out abrupt changes and minimize stress concentration points by understanding the principles outlined in this video. Both professionals and beginners can enhance their design skills and optimize their injection molding processes. Ready to level up your injection molding skills? For a step-by-step guide, check out our full Design for Injection Molding course at courses.3ddfm.com. Wall thickness mastery is just the beginning. In our next course, we'll take a deep dive into design for sheet metal fabrication, perfect for engineers working with laser cutting, bending, and forming. At BP Nell Consulting, we help businesses optimize their product designs to avoid common injection molding pitfalls. Whether you need expert consultation or in-depth training, visit us at 3ddfm.com. Subscribe for more expert tips on DFM, sheet metal design, and manufacturing excellence. Like this video if you found it useful, and drop a comment below with your biggest injection molding challenge. See you in the next lecture.